You guys love JavaScript. Cool. Say it with me. I love JavaScript. So, Rails. All right, so here's the deal. So this is an individual by the name of Dan Abramoff. Does anyone know who he is? Okay. It's a freaking legend. The idea is there are like certain quote-unquote celebrities in the tech community and world, and this individual, Dan, is currently working on the React docs for Facebook and is the father of Redux. I think a young individual, I think younger than me, I think he's like less than 30, but like, coding aficionado. Most people follow his blogs or his Twitter. He's a very cool individual, but this is one of the most important tweets I think he's made, and that is there's something fundamentally different about something called object.method. And then if you do this sort of var method and then assign it object.method, and then if you invoke method here or you invoke object.method, they will be very different. If you know why, then you'll learn JavaScript. Right? I think Andrew, like you met Andrew, right? He used to be like, oh man, just learn this and like you'll know JavaScript. Developers hate him. I don't know, that was really funny. Either way, the point is these two are very different, and we'll have to talk a little bit about what a method is, kind of because we haven't said that word in a while since Ruby, and then we'll talk about what the differences are here. So let's get started. So the first thing is, what is a method? Does anyone actually know? That's exactly correct. Yeah, whoa, powerful. So a lot of times in JavaScript, we say the word function. We haven't really used the word method. But in Ruby, everything that we did was a method. And according to that definition, a method is essentially a function that's defined on an object. And so really what we're looking at here is everything in Ruby is an object. So that means anytime you're writing a function, you're technically really calling it and invoking it on some sort of object. Therefore, it was always a method. That's why we said the word method. And in JavaScript, there's something called like a baseless function. And the idea is that in your JavaScript, you can have a function that's sort of just defined right here on the global, right? This function, isn't necessarily like attached to anything. It's like not nested inside anything. Yeah, you get the legs. This Mentos is like stuck in my tooth. It's like bothering me. Anyways, you have this function that's defined on the global, and it's baseless because you can see that it's not really attached to anything. So there's this idea that there are just like functions in JavaScript versus Ruby, everything is an object. If you write a function, it just inherently is going to be a method. Man, I'm sorry, I'm off. All right, let's actually talk a little bit about what this means. You can have a function, right? Object.method, sorry. Let's actually go through the steps. Cool. First thing is, all right, Dan Abramoff's question is, how are these different? Right? Hint, hint, it has to do with like the this keyword. We're going to talk about like the self and this and how they're different. We're going to recognize like why they're different. And then we're going to understand how we can actually use the this keyword, because it's been sort of like, we haven't really touched it yet. So I want to like explain what it is and how we can actually use it. And then when is the value of this set? And more importantly, when is it not set? So before we can even understand this, let's talk a little bit about self in Ruby. There are a lot of similarities between self and this, but they are definitely 100% different. Even lexically speaking, in the English language, if we talk about self and this, they're two different words, and words mean things. So when I talk about self, no matter what I'm talking about, every time I say the word self, I'm referring to what or who. Well, yeah, but I mean, like, if I were to be like, man, I'm not feeling myself today, like, who am I talking about? Right. It doesn't matter the context necessarily. Anytime I say the word self, I will be talking about me, myself, and I. Right? So if I'm like, man, I'm not feeling like myself today, or like even the word self, right, in that context will always be pointing to a particular person. Right? So if you were to say it, it's always pointing to you. If I say it, it's always pointing to me. But if you think about the word this, what does this actually mean? How does it get its meaning or definition? For example, if I'm on the subway and it's all like, just attention passengers, sorry for the delay, there's train traffic ahead of us, we'll be moving shortly, and I'm like, man, this stinks. Or I'm like, man, I really wish this class would say a lot more. Or I'm eating food and I'm like, this is delicious. Those three uses of this, did they refer to the same thing? No. So this keyword will always get its definition based on the surrounding context. And it only gets its definition when and where I say it. So if I'm like, man, let's look at this, and I don't point to anything, you have no idea what I'm talking about. Does that make sense? So the idea is that this only gets meaning and value when and where you say it, just even in English, right? Versus self, which is, it doesn't really matter the context that I say it. If I say the word self, I'm always going to be talking about me. So let's look a little bit about how Ruby does it. Inside this class person, you have a matter accessor of name. You can initialize this new person with a name. And then you have this def say self.say something. What kind of method is this? Class method, right? Because inside the scope of this class person, when I say self, I'm talking about the person. Now, if I had another method in here, right, which we can easily do. If I had another method in here and I said def, right, new method, I almost did this, embarrassing. Oops, what the? That was weird. What is self here in this context between lines 11 and 13? It will be the instance itself, because if I make a brand new person, right, like I do Andy, right, and I do person.new and put in Andy, I have Andy.name, but I also have Andy.new method. Notice how I'm invoking this method. This method is being invoked on the instance. So on this instance, self will refer to the instance, right? But self is always kind of pointing to a particular thing. And so the idea is that the way self gets its value is also a little bit with the context, but where it is written is really important. If it's written on line 7, inside the person class, it'll refer to the person. If it's written inside an instance method, it will refer to the instance. And we can kind of define what it should be referring to based on where it's written. But JavaScript's going to be a little bit different, but let's not dive into that too much. So self is not this. I want that to be very clear. Self is not this, right? You can kind of get somewhat understanding, and we'll start with like the 4 main rules of understanding this. We start with rule 3. In the same way that we had this class person inside of Ruby, what if I had just this dog object, right? Because remember, class person in Ruby just creates a person object. In JavaScript, I can already start with this object in general. I have this object dog, and I have a key of name, and it points to Winfield. And then I have a key of what is this? And inside that key, it points to a function as a value. What that means is, how do I get to Winfield from dog? What is the code? Dog.name, right? So name is sort of, looks like it's being sort of like invoked or called on dog, right? And how do I get to the function right there? Dog.what is this, right? So if you take a look, dog.what is this? It looks like this function is being called and invoked on this dog object. And if that's the case, then if I simply return this, dog.whatisThis, right? Because it simply returns this, will be pointing to the dog. So inside the dog object, this keyword will be pointing to and referring to the dog based on whether or not it's being invoked on the dog object. So far, so good. Nothing wild and crazy, right? Let's take this exact example and let's run some code. So I have dog.whatisThis here, right? So if I took dog.name, what should I get? All right, Winfield. If I put dog dot, and then you can even see it here, what is this points to a function. So if I put dog dot what is this, it gives me the function that just simply returns this. If I invoke it, what do you think I will get? I get the dog object back, right? Now let's take a look exactly at Dan Abramov's code here. I have object, which we know is dog, dot method, which is what is this, right? And then number 2 is var method is equal to object.method. So if I simply do var, right, a method is equal to object.method, so in this case it would be dog.method. And notice how here he is not invoking it. He's going to pass the reference to that function. So if I take a look at method, what should it be? Let me finish the thought and see if it's correct. I love that you have a theory. What is method? Is it a string? Is it a number? Is it too early in the morning? It is the function dog.method, right? So if I take a look at method, what the? Oh my God, that's so stupid of me. Yes, I meant dog.whatisThis. No wonder you were confused. Stupid. All right, what is method? Embarrassing. It's just a function. So far, so good. So if I triple equals them, what should I get, true or false? Let's do dog.whatisThis. If I triple equals them, what should I get? Method and dog.whatisThis. Should be true, right? We just invoked dog.whatisThis and we returned the dog object, right? Which is what this is, as we all agree that that makes sense. So what if I take a look at method, which is the exact same function as dog.whatisThis, what should I expect to get? If I invoke it.
Return this dog. Window. Yes.
I get the window object. So let's take a look at what's happening. Remember, dog.whatisThis is a function that simply returns what this is. So if I invoke whatisThis on dog, it points to the dog object. If I invoke method, right, what is method being called on? It's being called on the window object because the window, right, the browser is running your code. There's nothing that this method is being called on. So we can infer, even though method and dog.whatisThis is the exact same function, they have two different return values. And that will point to what this keyword is. Based on just this example alone, we can see very clearly that this keyword will get its value at the time of execution. It's not stored anywhere. It's not memorized anywhere. It gets it at the time of execution. When I invoked dog.whatisThis, right here, I got the dog object. However, when I invoked it right here, I got window because of what it's being called on and when it was called. Are there any questions? That was a terrible thing to say. What I should say is, who feels like they understand when this keyword is set. So okay, when is it set? Yes, at the time of execution. So the execution context becomes really important. Have you watched the 3.5-hour video I asked you all to watch? Okay, lie to me. Okay, very good, everybody, nice. Please watch that video, it becomes important. The idea is, here's the call stack, right? Nice and friendly. Look at this, no mouse. This is pretty straight lines. They're not straight. The first thing that happens, before line 1 even happens, the browser is going to pull in the HTML. Once it gets to your script file, the first thing that happens is what is known as this G, this global execution context. The browser is running your JavaScript, so the browser starts running everything. This global execution context is really the window. And so the first line of code gets pushed on top of the window object. Yes, no, no, yes. Okay.
Can you repeat that? I'm sorry. Lost train of thought there.
Very good. When you first run your JavaScript, Chrome or Firefox, Mozilla, Opera, whatever your browser is, will start to execute your JavaScript. It puts everything on this global execution context. So your first line of JavaScript sits on top of the global execution context, which is the browser. The browser runs your code, right? So if on line 1 I have a console log here and it's being invoked, that console log technically will go here. This function, this is meant to be an F, but I got cocky and then my finger slipped and I messed up.
Is the thing at the bottom, is that a method or is it a function or is it?
It's an object. I mean, it's like really everything sits inside the global, the window object.
It's on the call stack.
Mm-hmm.
You can have objects on the call stack?
Well, remember, it's running, right? This is like the global sort of like function, the execution context. It runs all your other code. You know how like DOM content loaded wraps everything? This is like before line 1 and after your last line, Chrome has to be running.
Right.
Because Chrome runs your code.
Confusing whether it's a function or an object.
Both?
Okay.
Not really. It's a process that's running.
So then, can it like be like popped or pushed off the context, or does it just stay there?
Remember, once your JavaScript's done, nothing else is running. But Chrome will still be running. Theoretically, like once you close the Chrome browser, this sort of goes away. And then you open Chrome again, the global starts. So far, so good. All right, I'm just gonna take it slow. So, that being said, I can have a very simple baseless function. That is a function on the global that just says, hey, say this for me. It's not attached to anything. It's not a method call, it's just a function. And I return this. What should it be? Let's think. Ready? I have a function that's baseless. And all it does is it returns this. That's exactly correct. You should return the window because it's not being called on anything. So far, so good.
So anytime something's called like in the global, this is the window?
Correct. Anything that's being called on the global will have to be the window. For example, how do I invoke this function? And bananas. What is it being called on? The window. So naturally, this baseless function is not bound to anything. It's actually executing on the window.
So does it have to be called anything? Or
Does it have to be?
Explicitly call on windows, like you're at the type of like window.basis. Not basis, like it just.
That is correct, right? It should default to the window. So for example, remember how is this syntax gonna break me? Right? Like fetch. Am I calling fetch on anything?
Technically on windows and URL really.
Technically on the window, right? I've shown this to you guys. So fetch right here is a function. It looks like I didn't call it on anything, but where is fetch coming from? It comes from the window. If I take a look at the window object, I can see everything that Chrome gives me that JavaScript can then execute, to include blur. Oh, blur, like that. If I run that function, I can tell it what to blur, right? Let's see, where is, oh, there it is, bam. Fetch is a Chrome API. I can call fetch from the window object. Fetch is not organic to JavaScript language itself, because fetch is asynchronous. JavaScript is a single-threaded, synchronous programming language. So anytime I have to do something async, it has to come from somewhere else.
So when you call something a basis object, it just means that it's not, or basis.
A basis function?
It's not, it just doesn't, it's not being called on anything specific.
Yeah. So actually, it's probably better if I just close the window. Oof. Like, where did that come from? Right? If I take a look at window, I could see that there's something in here called inner height. And that's going to be this window's inner height, this whole window's height, because it's Chrome the browser. This is the window that I'm looking at.
I have a dumb question.
I'm sure it's not.
Just, like, change the size of, like, the thing. I just want to see if it responds. Oh, no, never mind.
Well, it's because I've got it at the time of execution. I'm looking at the old window object. You want to take a look at this?
That's okay. It's just something to be useful, like, later on.
It won't like repeatedly evaluate because I've asked for it at this time. When I asked for it at this time, the height was different. Yeah?
Is the height based on pixels or?
I believe so, yeah. Like, I could be wrong. I think it's pixels. I'm not a master of the window object. It's very tricky. Cool. So how are you feeling about this basis function and the this keyword? All right.
So all of Windows properties like inner height and fetch, they're all baseless?
They're technically part of the window, but I just say baseless because that's not like a real term, so to speak, but the idea is that like it's not being called on anything. I'm just creating this sort of terminology so that we're all on the same page. As opposed to when I did dog dot what is this, there is sort of like this base object that it's being invoked on that we've created. Yeah. There's other things involved in JavaScript, like you can use something called useStrict, which will eliminate the global object. Like you won't be able to reference the window by default, but that's not important at all. So if you want to learn more about it, it's a really good blog post. Something called useStrict. So like on top of your JavaScript, you can do something called, I think it's like use, strict mode. Hold on. Oh man, I'm so stupid. Invoking strict mode. It's literally, yeah, use strict. That means that everything there will fall under a new set of guidelines. I think it's a really cool blog post. So, great. So here we are. Let's continue. Are we cool with these two rules? Right? Being invoked on an object at the time of invocation. This gets set. Baseless function. It will be the window object. Now, what if we want to force what the this keyword is? What if I want to say, whenever I invoke this, I want to pass in what the this value is? Yeah?
Would you like do this dot and some sort of parameter?
Correct, right? So there's a way to force what this keyword becomes. I want to take an object and have it bound to this function so that this keyword is always set. For example, right? I have person 1 that has a name of Andy. I want to force person 1 to be this keyword in my function. What I can do is I can have a function like that, for example. I'm trying not to say the word this because it becomes very confusing unless I'm referring to this keyword. So I have person 1, and I have person 2, I have person 3, and I have a function that takes in 2 arguments, a location and a time. All it does is it returns this .name, says hello from location and time, which are the 2 arguments that I'm passing in. So if I simply look at the function say name, it's the function that I just defined. So far, so good. If I invoke it, what will I get? What will this .name evaluate to?
Whoever you call it on.
That's what I want to do. If I do it right now, what is this .name? Technically, this is what when I invoke it right now. If I were to say name with the bananas, what does this point to? The window, right? We just learned this right here. This points to the window if I just invoke say name. I heard a bunch of weird answers that wasn't window.
Why would it not refer to the same function?
This is a very good question. Why does this not refer to the same name function? Because it, in the same way that Ruby does the class, inside the person object, the way self is evaluated, it points to the person. So you're thinking this should probably point to the function.
Right, like through scope reasoning?
It's more like the way to read it is, in the function say name, what does this point to for the function say name? It's not necessarily this line that goes, what is this? It's more like this function, what is this keyword for it? So what is this keyword for say name? What's to the left of say name? Which is nothing, right? Which would point to the global object because of scope, which is the window. It's not necessarily on this line, look out. It's more like this function, it's this.
That's tricky.
It is very tricky. That's why I'm taking it step by step. Good question. And then Ariel.
So if say name is being called on the window, it just returns the whole function, like the whole say name function, rather than just the inside return statement.
Say again?
So if say name is just being called on the window there,
Mm-hmm.
the return is just the whole say name function rather than just the inside body.
Yeah, I'm asking what is say name the variable. So it will return to me the entire function because say name is a function. Yeah? In the same way, if I just did var, right, Sophia, right, and I'm gonna have a quick question. If I ask for what is Sophia, what is it gonna give me? Just the string QQ, right? Like if I say what is Sophia, it's just gonna give me what this is pointing to. Say name is a function, so it has to give me back the entire function. Aaron, you have a question?
So, I guess just like coming from, so like this is going to be something that's acted on all the time. So I guess like the whole thing about like the function
Mhm.
So that leaves the window as if it's being acted on, so that's where the window is this.
Yes, the window is being acted on, so to speak. Correct. Because the window, right, the browser, is running your JavaScript. Okay. So if I invoke say name, what does this dot name evaluate to? Or what does this evaluate to inside this function if I invoke it right here? The window, right? That means it's going to be looking for a key of name on. Great. By default, the window has a key of name, and it is always empty string. So that being said, if I invoke say name, what should the return value be? Empty string says hello from whatever arguments I pass in. So if I say name and my location is K and my time is now, I will get change tool. Chrome is so fast. Like every time I do this lecture, Chrome is making updates.
I typed window.8 on my computer, it stays empty string.
Yeah, I think Awesome Web App might be changing it. Hold on.
I'm on Stack Overflow.
Yeah, this should be empty name. Hey. Yeah, I think Awesome Web App overwrites the global object. Change tool, embarrassing. So anyways, yeah.
So if you have some sort of, like, if this is called on something that the window doesn't have as a, like,
Yeah.
attribute, then we'll just return an error.
Well, remember, the window is an object, right? In the same way that if I had a const object is equal to this, and I had Benny, right, which we obviously know is here. And we have Chet, which we know is Chetty. Oh, the Chets. The Chet. And its proper name, clearly, 100%. Whoops. If I call a key on this object that doesn't exist, right? Like, I don't know, this loser right here, what do I get back? So if I do window dot yaboy, yanoi, undefined. So, continuing on, right? The idea is that I want to force what this keyword is. There's 3 ways to do it. I'm just going to show you the 3 ways quickly, but I'm going to focus on the one that's most important. The idea is that if I do something like say name, let me show you. I'll just show you all of them, and I'll just focus on the one that's important. There's something called bind, call, and apply. Probably should have been written in a different order, but it's fine. Bind, call, and apply. Those 3 things can force what the this keyword is. It will lock in what the this keyword is. And what call does is you can invoke call on a function. And how many arguments does say name take? 2. How many arguments are in here? All right, you could see a location and you can see a time, which means that call is being called on a function, and you have to give it 1 extra argument, which naturally would be what you want this keyword to be. So for example, if I have say name dot call, I can invoke dot call on a function. And now I need the regular arguments it needs plus what I'm forcing the this keyword to be. So I'm forcing the this keyword to be person 1. And then now I want the location to be school, and I want the time to be now. And it says Andy dot says hello. Why would it be Andy? How did it get Andy? Right. The object person1 has a key of name that points to Andy. So what I'm trying to say is if I forced say name to have a very specific this object, what I'm telling it is that this object is now person1. So if I do person1.name, I get Andy. So really, what I'm really doing is somehow inside say name, I'm replacing this with the object person1 if I use call. Notice call is being invoked immediately. Right? When I do .call, it automatically returned immediately. Call will invoke the say name function. So far, so good. I just forced what the this keyword is by using call. Now, I can also do apply. And the only difference between call and apply is that how many arguments are in here? Okay. How many arguments are in here now? So the difference between call and apply will ask you for an array of all the arguments. Technically, it's an array object, so that it counts as one argument. And it will invoke your function immediately. So far, so good. Any questions on call and apply?
So for apply, you don't have to put person1 in the array because that's not technically like one of the arguments.
Correct. Just like call, apply, same thing. The first argument is, what do you want to force this keyword to be? And then, what are the arguments you want for the actual function?
Is it like standard to always have whatever you want to force this keyword to be the first argument?
It has to be the first argument.
What would be a good example that you could give us where .call would be used as a number where .file is used?
I'm going to give you an example. If you do not understand it, we'll talk about it later. Okay. Inside of for each, you can force what this becomes by calling .apply on it. And remember, for each is going to take an array. And you can force what the this keyword becomes on the this keyword for every item in the array. If you don't understand that, that's okay. We could talk about it later. All right, so let's talk about the last one, this bind. This is the most important one. If I look at the syntax, I'm simply doing .bind, and all I'm doing is passing in what I want to force the this to be. So if I do say name.bind, I can force it to be any one of these objects, right? Let's just do person2. And I hit enter. What do I get back?
Another function.
That's right, I get back a function. That's the return. So notice how call and apply will invoke my function. But with bind, for some reason, it gives me a function back. Remember, we're always thinking about what the return values are, the data types. That's so important. If that's the case, then bind does not invoke your function, but will return a copy of your function that has forced the this keyword to be what you want. So now I can do something like const, right? Bounded or binded say name function is equal to say name.bind, and who do you want to bind it to? Person 1, 2, or 3?
3.
Sure. Person number 3. So if I take a look at binded say name function, I get a function, and it still says this. But what happens when I invoke it with a time and location? What do you think that this keyword will be? person 3. So if I invoke this with a time of, location of Neverland and forever, it automatically has a reference to what this should be. And that's going to be person 3, which we can tell from here, person 3 is in fact Gary.
Would you get the same result if you just called where you go, like, say name dot bind person 2
Well,
without like binding it to
remember, I've lost this because I don't have a reference to it. It just returned me a new function, but I can never really use it because I don't have a reference. That's why I had to create a variable and store the new function. It is a brand new function with the this keyword locked to it. So let's take a look at binded say name function and see, is it still the same as say name? No, it is different. There are two separate functions. One has a this keyword that is locked and set. The other one, the this will evaluate at the time of execution. So bind will return a new function with the this keyword set to whatever you want it set to.
You just throw some bananas after saying name dot bind person 2 and invoke it right away.
Oh, you mean this?
Throw some bananas.
Yeah, I can invoke it right away because it returns a function that can then be invoked, yeah. And then I would put the arguments here. Correct. Any questions on bind, call, and apply?
So sorry, just to clarify one more time.
Please.
When you do the const binded say name function, that's when you're like setting the this keyword to something that like stays or that is always the same this keyword. Like sorry. When you create a constant, that is this keyword value is going to stay the same.
Right, inside binded say name, it is technically a new function where the this keyword is set, and it's set to person 3.
And then when you call binded say name function with the two arguments that you passed in, that's when the this keyword depends on or is given a value when you execute.
Technically, because I've binded this inside binded say name, it's always going to point to the person 3 object.
But it's given the value once it's executed, right?
No, it's given the value here when I bind it.
So then what were you saying then when it's like one?
Okay, binded say name has a this. It's locked in. It's person 3. Say name, however, will evaluate the this at the time of execution because there is no forced this keyword set in stone on this function. Does that answer your question?
Yeah.
Okay. Any questions on bind, call, and apply?
If you change the object after it's been found, will that change what the function does, or is it like a copy instead of a reference?
It's a copy. So I can't really technically, I can do it on this, but it would give me a new copy again.
I mean, if you change person 3 and then call binded say name function, would it
How can I change person 3?
change name? Say person 3 dot name is equal.
Oh, I see what you're saying. So you're saying like person 3 dot name is now equal to Evan. So if I say binded say name function,
Okay.
because objects are passed by.
Reference.
Very good. Good question. Now you're learning, putting it all together. Smart. Notice how we mutated this data, and it can have side effects. It will change how things are run outside. Right? We'll learn about what is known as something called immutability, and that is I want to make sure that I don't change, I don't mutate things so that I don't accidentally do something like this. This is a functional programming paradigm, which is important. Great, so we went over 3 of the rules, right? Bind, call, and apply. You can force this keyword. We talked about how general rule of thumb, whatever's to the left of the dot, general rule of thumb, not always the case. This keyword will evaluate and point to the object based on the method. And then we talked about a baseless function, and that pointing to the window object for this keyword. So far, so good. Now, there is something else. This is going to segue into part 2 of this lecture, is what is known as the constructor function. If I have a function, right, in the same way that Ruby has this class person, I can use this new keyword, force it, and then this sets the self to the person anytime I make a new person, right? Like if I do person.new and I pass in Chet, and I have Chet here, and I do Chet.name, it's pointing to Chet. If I do person.new with Andy and I do Andy.name, it points to Andy. It's just, this class is just creating objects for me. So, inside here, a constructor function is a very fancy way of saying that this is just going to create an object and it's going to force this keyword to point to the newly created object. So, I have a function, person. I capitalize the first letter in the function to let other people know, other devs know that this is a constructor. It just has some arguments, and remember what it's trying to do. I'm just trying to create objects. I put this.name is equal to name, the argument I put in, and this.favorite color is equal to favorite color, because I'm trying to set this keyword to the newly created object. So if I make const Andy, and remember, JavaScript's just a little different. It's new person, not person.new. And I pass in Andy and red, I get Andy, which points to the person object. And if I do type of Andy, Andy's a person. If I do Andy.name, what do I get? And if I do Andy.favorite color, what do I get? Right. So the trick to the constructor, and we're going to talk a little bit more about it, is that there's no return value. It is implicit because I use the new keyword. The new keyword creates the type of object and returns an object with these sort of attributes. As you can see here, name, Andy, favorite color, red.
So this in the function, like this.name and this.flavor, they're mostly for the new instances you're creating?
Yeah, it's going to bind the new instances to this newly created person object. This is going to be very important as we talk about inheritance, which is we're going to start right now.
Should we relate this amount of range to the initialize in Ruby? Or are they close?
Correct. I'm going to get there. So, any questions on this and the 4 rules? All right. The last thing I want to talk about is the arrow function. So, we have an arrow function, and that is this arrow, it points to an object. If I put say this, which is an arrow function, and I return this, why is this arrow dot say this the window? It's different, right? All I'm trying to explain here is that something about the arrow function changes the way this works, right? Because remember, we had dog here, then we had dog.sayName with the function keyword returning this pointed to the dog. When I change it to the arrow function, for some reason, it's not pointing to this arrow anymore. It points to the window. You had something to say?
I was just going to say, because I don't know if this is for sure, maybe the arrow function just runs it on the window.
The arrow function, right, as we've learned, and I will show you, runs dot bind. The arrow function will bind this. So let's take an example. Ready? I have this const dog, right? If I do dog.name, what should I get? If I do dog.favorite snacks, I should get an array. If I do dog.eat snacks, what is that? A function. So let's step through this function step by step. If I do dog.eat snacks, it's a function. I can invoke it. What is the this keyword inside here? The dog object. So dog.favesnacks is in fact the array. We just talked about that. So dog.favesnacks is an array. Can I invoke for each on an array? Yes. Now look at this callback here. Tell me what you think dog.eatFavoriteSnacks will be.
And the string is eating.
I get Winfield, right? Now let's do some tiny mutations. Let's take this. Boop, and let's use doggo, because I can't use doggo again because it's a const, right? Oh my god, it's embarrassing. I use doggo, and now let me recreate this, comma, and I put eat snacks function. And that points to a function keyword. Boop, boop. I hate writing in the dev tools. Okay. So instead of the arrow function, I'm going to use the keyword function. Function, and it receives a snack object. So far, so good. All I did was convert it from keyword to function. So what happens when I do doggo.eatSnacks function? What if I invoke this? What will I get? I get the empty string. So let's talk about what's happening here. The idea is that this function, for each, will receive what? What does for each receive as an argument? A callback, right? Let's take this very slowly, step by step. Who agrees that this is a callback function? Great. What have you all been doing inside your fetches? You've simply been doing function, right? This is going to be the snack eating callback. And then what did you do? You literally extracted it, right? You took this callback function, which I'm going to rip, and I'm going to pull the exact code. Notice how I just ripped it out. And now what do I put inside this for each? Snack eating callback. Where is this function defined? On the global, which means that this keyword inside this callback will be the window. So inside a callback, the callbacks are baseless functions. They're not being invoked on anything. The for each function will call the callback for every item inside the array. Yes. The for each will invoke this callback for each item. So this right here will receive a snack. This might help. Let's build our own for each. This lecture's running really long. I'm going to finish this lecture. We'll break for lunch. I'll have a lecture in the afternoon, and then we'll continue part 2 after lunch. So the idea is that I can have my own for each method, right? I can do function, and I can say my for each. How many of you have built your own iterators? Did you do the labs where you built your own iterators? Great. Naturally, if I'm doing an iterator, I need what? I need the array, yeah? And then I will probably need what inside of it? The for loop, and it's going to go through the array. So far, so good. The for each, right? What does for each take as an argument? A callback, right? Callback. For each takes a callback, yeah? So, let's think through. My for each, I'm going to go through every single thing, and for every item in the array, I'm going to invoke the callback. So, array at index I is each individual item. All I have to do is invoke the callback with each individual item. So far, so good. Now, how do I actually invoke my for each? Well, I do my for each, and I pass in the array. So I'm going to have an array of 1, 2, 3. And then I pass in a callback. I have 2 options. I can either write it right in line, or I can pass it a function. For example, snack eating callback. I can just pass it a function that already exists, or I can write one in line. Yes or no? Okay. Let's read through and see what happens if I write it in line. This function is going to receive one of these elements at a time. So it's going to receive some sort of number. And all it's going to do is console log the number. Now let's take a look at what's happening. I have function my for each. It takes in an array. Great, I have an array, cool. And it takes in a callback. And here's the callback, I've just passed it. If it helps, I'm going to separate this, and I'm going to separate this. You okay? Okay. Now, this callback is being invoked here. So in the for each, in the loop, what is array at index I on the first loop? Here. What is the value of array at index I? 1. Array at index I will be 1, 2, 3, but in the first loop, it's array at index 0. Index 0 is the first item. The first item here is number 1. So that means that I am, in theory, passing what number to this callback in the first iteration of the for loop? 1. And then I'm going to pass it, and then I'm going to pass it 3. So what happens when this callback gets invoked with 1? Well, it invokes this callback, which I'm going to look to see, well, where is the callback? The callback I created straight in line. So it receives a number, 1, and then it console logs it. It receives a number 2, and then it console logs it. It receives a number 3, and then console logs it. And then the callback is complete. Let's take a look. My for each takes an array and a callback. Now this function is attached to what? Should be nothing. It's attached to nothing. It's just invoking the callback. This callback is just being invoked. And I built it in line. I don't have to build it inline. I can pull it out. So let me do that. I'm going to just have a function that's the callback. And all I'm doing is it receives a number, and all I'm doing is console logging the number. So this for each can receive what? The callback. Remember, this callback is being invoked by the for each. What is the this keyword for the callback function? The window. This is a baseless function. So the callback is essentially a baseless function. Regardless of whether or not I've pulled it out or if I wrote or if I created it inline. Because the for each will invoke it. I just can either pass it a callback or I can make it right in line. It gets a number and then I console log the number.
So in both cases, this for that function will be the window. In both of those cases, this for the function will be the window.
Correct. In both cases, this for the function will be the window because it's just invoking this callback. Think about what this for loop is doing. If I didn't want to create the for loop and I wanted to hard code it, I didn't want to do this. My for each is going to take in an array, right? Let's just say the array is 3 items long and it has numbers 1, 2, and 3. I'm basically doing this. Callback with 1, callback with 2, and callback with 3. That's all I'm doing. It's just not as dynamic or sexy. I'm hard coding it in. This callback is really a baseless function. It's very hard for me to read where you are unless you talk to me. Yes?
But the lines 26 to 28, like the callbacks, they're not technically being called on anything, right? Like they're not.
They are not being called on anything. That is correct.
So in that case, are they not referring to the window object?
If they're not being called on anything, they're a baseless function.
Okay.
So baseless function has what for the this keyword? Right. The baseless function has the window for the this keyword. So, one more time. Eat snacks. Inside the function keyword, I have this dot favorite snacks. So inside this right here, this scope, what is this? Inside a function. Function keyword, what is this? Who says it's the window? Who says it's the doggo? It's the doggo. Surprise. Does anyone want me to explain that? Okay. Dog. What is this? With the function keyword, this points to what? Because of how will it be invoked? Yeah? So we've established that inside here, this is the dog. So this is the dog. This .fave snacks is the array, which I can invoke for each on. And then it gets a baseless function. So inside snack eating callback, what is the this keyword? The window. So far, so good. So that being said, let's continue. Actually, I have it here, right? Yeah, I have it here. So that means that if I have a function, which is a baseless function, and I do the exact same thing here, what is the this keyword here? Who thinks it's doggo? Who thinks it's window? Who needs like 2 seconds to evaluate?
You said it's baseless. It's like a baseless function calls.
That is correct. What do you think it is?
What?
What do you think it is?
It's the window.
It's the window, right? Now, what if inside this baseless function, I'm going to put a space here so that the for each ends, oh man, that was embarrassing. I think for each should close there. There you go. So we see the callback here. So far, so good. What if I wanted to force what this points to? Instead of being a baseless function that points to the window, I'm forcing it to be dog. How would I do that? Knowing what we learned about how we can force something to be this keyword. Yes, I can bind and pass in what do I want to bind. Do I want to bind person 3? I want to bind the doggo. So far, so good. I'm now going to remove the extra obnoxious spaces I put in because it's kind of silly. Did I do anything crazy? I just binded the dog. So if I run eat snacks function on doggo, doing something like doggo dot eat snacks function, what should this be now? It should be Winfield is eating cabbage, Winfield is eating carrots, and Winfield is eating bones. Because I forced this keyword to be the doggo object. So here, if this is the doggo object, there is essentially no difference.
If you have used the arrow notation.
You mean right here?
Okay, sorry.
Now, these two are exactly the same. So the only difference is that the arrow function, I'm sorry for those that don't fully understand, the arrow function will bind this keyword. What the arrow function will inherently do is do this. Remember, this dot fave snacks, what was this on line 20? The doggo, right? This right here is the callback function. That's the scope of the callback function. So far, so good. Outside the scope of the callback function, we are now back in the doggo. So in theory, this will point to the doggo here because it is outside the inline callback function. So I'm just going to bind this, which is the doggo. So the arrow function will bind this, literally bind the keyword this to whatever function you are writing. That's what the arrow function does.
So basically, in order to like bind a callback function, you just use your arrow notation.
Or write dot bind.
Which version of this syntax is best?
Best practice, modern JavaScript says you should understand the arrow function, so you should just be writing arrow functions if you're intending to bind this keyword.
I don't know if this is like not the right way to think about it, but so the arrow function kind of binds one level up, or it like looks at this.
It will bind whatever this keyword points to at the time of execution.
Okay.
Yes. Why would I not want to use the arrow function, right? Natural question. So before I move on to that, are there any questions as to the function keyword and the arrow function in the example on 14 to 22? No. Okay, great. So let's create another example. And let's put all arrow, like eating, eat snacks. Cool? Now, what's the first thing we see here in how we declare a function in both of these examples? Is it the arrow function or is it the keyword function syntax? Correct. Now, let's think this through. If I use the arrow function here, remember the arrow function will bind the this keyword to the key. So this right here is the arrow function, yeah? This right here is the function keyword. The arrow function will take whatever the this keyword is. Notice where this is declared. It's declared inside the scope of doggo. However, the this keyword at this level is what? If I were to say this, what is this here in the scope? Dog dot what is this has to be the dog be based on how to invoke it. So far so good. Inside the context of doggo, right? This keyword is the window. It's not until I go inside one of the keys can I do dog.name. So only inside the key will this point to the doggo object. This, however, inside the context will be the window object because I can't actually invoke this keyword on the dog object. It must be inside a key. So this right here, outside the context of the key, technically this is the window. It's only inside the key because of how I have to invoke it will this keyword point to the object. So still here, this is the window. That means that the arrow function will bind this right here if I do the function syntax. This is going to be exactly the same as this, which means that if I bind this here, this is outside of this. So this right here should be the window, which means that if I do something like this dot fave snacks, it technically will not point to the array that I want anymore. So one use case for the function keyword is if I do not want to bind this keyword, I create my own execution context. I understand that all arrow eat snacks, function keyword. Inside this right here, this keyword becomes the doggo. So if I use the arrow function here, it will break. So not everything should be an arrow function. Just be aware. Sophia, you got a question?
Is it like bad for me to think references the dog, but if it's not within a key, then it references the window.
Without confusing anyone else, I'm following what you're saying. So yes, I'm not going to repeat that because it can be confusing.
Why in the example that right there would an arrow function break on line 27?
Great. So I'm going to have, okay, this is for you. All right, so example 1, just so we can reference it easier. So these two are exactly the same. So far, so good. This keyword is going to be the window. And so if this keyword is the window, what is window dot favorite snacks? It would be undefined. So if I put for each on undefined, that'll throw me an error. Yeah? Any questions on this arrow function and how it binds this? Great. Let's talk about the different versions of the arrow function, and then I'll let you go to lunch. Cool? Okay. I must have removed it from the README. So there's a few ways the arrow function can help you. If you have one argument, right, function like one argument, right, and I just have an arg here, I can also do const one arg is equal to an arrow function with one argument. And I would just put that one argument right here. So far, so good. If it is one argument and one argument only, you do not need the parentheses. So you might have seen this in your .bends, where if you get one argument and one argument only, like a response object, some of you have written it this way. Okay. The next thing I want to talk about is if you have an arrow function with one argument or no arguments, whatever, if the return is one line, so let me do this. If the return is on one line, you do not need the curly brackets. So if I said 7, this function, this function will return 7. Sorry. I do not need the curly brackets, and it has an implicit return. I do not need to write the word return, and I do not need the curly boys if it's one line. So for example, you might have seen something like this. Response is one argument. You do not need the parentheses, but I will put them in. And you wanted a one-line function. Just putting some extra space so you can see it. If it's one argument, you remove this, and you don't have the curly boys because it's one line. Here's the pitfalls of that. How do you debug this function? Do I just do, oh man, let me just drop a debugger right here? That would be crazy. You have two expressions on one line, and JavaScript doesn't know how to do it. So if you ever need to debug something, you can change your one-line implicit return arrow function into a multi-line by simply adding the curly boys, putting it on separate lines. But now you have the curly boys, it's multi-line, you must return. But if I wanted to debug it, it doesn't matter. I can put the debugger here, or I can put the debugger here. So you need to learn how to convert the one line into multi-line and understand where you want to drop your debugger or your console logs. Are there any questions on the arrow function and how it binds this, the implicit return, the one-liner, the no parentheses if it's one argument? Sophia first.
So you just laid out like the different versions of the arrow function.
They all bind this.
Yeah, but even if you don't need the parentheses, if like it's only one argument, or you don't need the curly braces if there's turns to just one line, can you have that if it like helps you?
Yeah, you can put the curly boys and return on one line if you want to.
What happens if you leave out the curly voice so it has an implicit return, but then you're doing something like console.logging, so it will return the console.log?
No, it will try to evaluate and return two expressions and it will break.
No, if you just have a console.log. So if you're like res to console.log,
On one line, you want to remove the curly boys and you want to do what?
just surround res with console.log.
That's technically one expression.
Right, but it's doing an implicit return, right?
Correct.
What is that bad? Because
This right here?
yeah, because it will return something that's not supposed to be returned.
It will return this line. And what that means is response.json will parse and it will be some sort of response object. And then it will console log. And then console log returns what? Correct, undefined. So if you do this on one line, it will force the implicit return on a console log. So you will see the console log because it will run it, and then it will force the console log to return, which is undefined.
Okay, so it won't, it's essentially identical to having the curly voice, because undefined, returning undefined. Oh, sorry, that's muddying the waters. Okay.
Okay, if there's no other questions on just the arrow syntax or the this keyword, that's all I have for you this morning. Thanks.